Yeah, all good now. I think should be good.
Okay,
Yep.
okay, no problem. Hi guys, my name is Maina Wycliffe. Uh, Currently, I'm a software engineer at Skyhook Adventure. We are basically a travel company, sort of like Safaris. Actually, not sort of like Safari, actually Safaris. And I'm a full stack developer. So basically, my day involves a little bit on the front end, a little bit on the back end, and DevOps. So basically, I do a little bit of everything. And one of the most amazing thing about our company or the current state of our tech stack is that it's about 90% TypeScript. So on the front end, we use TypeScript. On the back end, we use TypeScript. And also for the IAC infrastructure as code, we usually use AWS CDK for TypeScript. And this has inspired me to go on a journey over the last few months, starting late last year, of understanding and teaching TypeScript. So I feel that developers need to learn TypeScript in order to get the most out of it. And by understanding TypeScript means you avoid most of the pitfalls most developers usually have that make their code less type safe, because TypeScript is here to provide some sort of safety, even if it's not during runtime, but at least during our build time. Like I should say, it avoids us making the stupid mistakes we make. So let's get started with today's session. So the question you always need to ask yourself whenever you're thinking about TypeScript is, what is it? So if you ask, people give you different answers, and there will be probably one of the first two here. It's either a JavaScript superset, meaning TypeScript doesn't have any runtime, so it gets transpiled to JavaScript. And then the other one is it's statically typed. This means that the types are defined during build time or during coding, and then checked during compilation process, and any errors are caught at that point. So like I said earlier, it has no runtime. So the cost of TypeScript is, as we should like to say, it's zero, but not necessarily zero, but near zero, because most of the code you write in TypeScript get discarded when compiling to JavaScript, apart from things like enums. Another additional advantage of TypeScript is it provides additional tooling like language server, which is very important because most JavaScript developers don't really understand this, is that because of TypeScript, they're able to get what we call suggestion or completion on their editor because of TypeScript. And there are TypeScript language server, which is able to understand not only TypeScript types, but also JS docs, and able to offer suggestions and sort of like linting so that you don't make typing related mistakes. So we talked a little bit about types in TypeScript. That is, it provides static typing. So what are types? The way I really like to think about types is that it's a declaration of intention, whereby you say what you want, and TypeScript checks your program and says, or checks your code and looks at it and says, your code either matches to your intention or doesn't. When you declare a variable of type person, where person has three fields, if you don't provide all three fields, TypeScript is going to look at that and say, hey, you are missing this field. Hey, you added this extra field. Those are the kind of things that that's what I'm meaning when I say it helps you declare your intention. So TypeScript is able to use your intentions so that to type check your code. So whenever you're writing your intention, you can you're writing types. You can think of it as a way of telling TypeScript exactly what you want. And so that the TypeScript is going to check at those types and use them as parameters to make sure the program behaves accordingly. When you write a function that accepts a string and returns a number, you can't return a number and it can't accept a string. And these are the kind of things you have to think a little bit about. And this is where TypeScript helps you, because sometimes our own intention, we forget what we intended to do. But by looking at our types, we're able to understand this a little bit better, knowing the shape of the data we are trying to match or we are trying to manipulate. Because at the end of the day, coding is about data manipulation or moving data from one point to another. And this either through events, either like light events, IO events, The whole concept allowed coding involves allowed how data moves allowed, and types helps us do this very well. Another thing to understand about types is that they are set of values. What do I mean by this? If you say a variable is of a type number, you are saying that variable's value that it can accept gets limited to only numbers and not strings. The same applies to string, where it gets expanded to all strings that exist out there, but not any numbers. And the best way to think a little bit about types as a set of value is when you're talking about unions, whereby something could be either on or off. And in this case, you're limiting the set of values that variable can accept to on or off and nothing else. And this concept can be expanded to numbers, which go all the way to infinity. The same thing to string. Boolean are a little bit binary in that you either get true or false. And when it comes to the famous any type in TypeScript is that it has no restriction, could be anything. So in this case, the set of values it can accept gets expanded to everything. Like I said before, the same applies to unions. So let's skip that. So let's talk a little bit of an interesting topic for me, or something I really like to talk about when speaking about TypeScript. It's the concept of type narrowing. So when you have a type that has an imprecise, let me use the term imprecise here. It's on my slide. What I mean by that is we are talking about a variable whose type could be more than one combination of type. Maybe if you look at the example below, we have an input whose union is either it's a union of number or string. And like we have said, this gets expanded so that it accepts all numbers and all strings. The question is, what do you do when you want to use it as a string? And this is what we call type narrowing, whereby we are able to check, we are able to look at that type, do an operation on that type, a control flow check, checking the type of that type, and then using it appropriately. And TypeScript is very clever with this in that it checks how you have used, your previous code and how you have used it, and determines the new type, the new type of the input inside the control flow. So in this case, as you can see, I have an input. I'm checking the type of input. Type of is a JavaScript operator that basically exposes the type of the underlying variable. And by basically comparing it to string, TypeScript is able to see within the scope of that if block, that type is string and can be used as string only. And once you go to else, that becomes a number and can only be used as number. So this is why I'm saying TypeScript is very clever in that it's able to analyze your code and how you have applied different things in your code and able to determine the type at that exact point. So let's look at various ways we can narrow types, because TypeScript does provide a number, not just a number of tools, but TypeScript and JavaScript in general do provide a number of tools to enable you to determine the number of the type of a type. So the first one is type guards. These are basically JavaScript built-in. They are about 7. So we already talked about type of, which just checks if it's string. You can check if it's a number. You can check if it's a boolean. You can check if it's an object. And I think an array, if I'm not mistaken, and a few others. And basically what this allows you is to check the type of an input before using it. And one of the beauty of type of or the type guards is that they are available in runtime, meaning they don't just apply to your code during build time. They also apply during to your code during the runtime process. So meaning their safety extends all the way to the runtime, meaning your data when running in a JavaScript environment, either via the browser or Node.js or Deno, won't get corrupted. So the second one is truthness narrowing, and this is one that I think we are very familiar with, whereby we check if the value of a variable is truthy. So this usually checks against undefined and null, so that if it's anything other than that, the type gets narrowed automatically. if you look at that example I'm giving there, whereby I have an input of string or undefined, if I check if it's truthy, that is input is truthy, then that type becomes automatically nulled to string within the if block. The third one is instance of. This mostly works with classes, and also this is also available in runtime because it's JavaScript thingy. And let me point out all this. The next few operators I'm going to be covering are available in JavaScript. So instance of basically checks if a variable is an instance of a class. So we have an example here where we have an input which could be either string, maybe an ISO string for a date, or a date object, so allowing that flexibility. And what we are doing there is checking if input is instance of date, and that gets nulled to the date object. Otherwise, it gets nulled to the string object. And you can do something very clever here. Maybe this is something that it's a string method which converts the input into a string, but it could be a string that is accepting a string. In that case, you just return the input. Otherwise, you just take the date object and convert it to string. So these are the kind of things that you can do with nulling that will allow you to write a very safe object, because if you did not do that and someone decided to pass in a string, then it would probably fail. So the last one I'm going to check here is going to be the in operator. And I have to insist these are not this is not a conclusive list of nulling types. There are way more, including things like assignment nulling. But for now, let's focus with the in operator, which is basically another JavaScript operator, and it checks if fields exist in an object. So in this case, we have two types. One is a circle, and the other one is a rectangle. Well, I've been saying I'll fix that typo for a very long time. Anyway, so in this case, what we are doing is checking if radius exists in shapes using the radius in shape. And in this case, TypeScript is very clever by looking at that and saying shape exists in circle but doesn't exist in rectangle. So it automatically narrows the type to shape, the type of shape to circle. And if you are to add an else in that if block, it will get automatically narrowed to rectangle. And these are the kind of things you can do with nulling, in that by understanding a little bit of how TypeScript works, you're able to write a much more safe code that's a little bit less brittle. Because like I said earlier before, these types do not exist during JavaScript. So you have to make sure you catch all the errors, or as many as you can during the compilation process, because TypeScript provides static typing rather than dynamic typing or on runtime. So then there's this one. This one now do not exist during runtime, but basically we call discriminated unions. And in essence, what this allows us to do is that we can add a literal member in each of our own object, and then we can use to check if that object, if the shape that object is of a certain value, then that type gets nulled. So I'm going to use this example of rectangle and circle that we used previously using the in operator. And in this case, we are going to be providing a shape or type of shape, little member of either rectangle or circle. And if you look at the function that calculates the area, which accepts both, it is able to say it's able to determine the type of shape by basically looking at that little member of shape and compares it into rectangle. And TypeScript is going to cleverly look at that code and be able to see when it's rectangle, this has width and height, so it must be rectangle. And when it's circle, it only has radius, so this has to be circle. So now we have talked about various ways you can narrow types in TypeScript. And another advantage, another thing we can do with TypeScript is that if you have noticed something, if you had an object with, I don't know, let's not say 100 fields, maybe 10 fields, and it was used in a number of places, this could get annoying very fast. So what TypeScript allows you to do here is that you can create what we call custom type cards. And in this case, what this allows us to do is create a function that returns what we call a type predicate. Predicate is something is in the form of shape, is rectangle, whereby shape is the argument of that function, and that function needs to accept just a single argument. And then is it's what asserting it to, and rectangle is the type we want to assert to. So in this case, if you look at this function here, which is called a rectangle, or let's call it a type guard, we are able to sort of like use JavaScript, or you can just use almost any other narrowing type guards and things like that we discussed previously, to sort of like inspect the shape object and determine the fields in it before returning true or false. So if this function returns true, then the TypeScript will automatically assume you have done your due diligence, and then it's able to assert that type or narrow that type to rectangle. Otherwise, it's able to say that is not a rectangle. Moving on from narrowing, it's I usually love to discuss about unknown and any. So for those of you who are not aware, TypeScript has a type known as unknown, and this was introduced in version 3.0. And then we have any, which has been with TypeScript since day one. So any when a type or when a variable has a type or is of type any, TypeScript usually doesn't do any type checking. So if you say circle dot dot height, TypeScript doesn't know what is inside that circle, so it's going to assume you know what you're doing. So TypeScript introduced a known type, which is for types that you don't really know the type. And the key difference between the two is that TypeScript doesn't allow you to use a variable whose type of unknown before you can do narrowing. So if you looked at the previous screen, you used unknown when you are creating a rectangle. Let me just go there. So when you are creating an rectangle custom type guard, you see we are naming shape as unknown. And in this case, we cannot use this shape unless we narrow that type. So avoid using any is usually my golden rule, but there are some edge cases where any is acceptable, especially when you are dealing with a mixed code base of TypeScript and JavaScript and you're doing migration, or the object you're typing is large. But the one thing I should like to advise people is use any only as a last resort. Do not use it as a way to avoid creating proper types. So avoid using any is, I guess, the general advice. So another thing that I really like to talk is assertions in TypeScript. I have a C# background, so I usually use casting a lot, so I might end up calling it casting. But what this allows you is to convert types, but rather not in the traditional sense where you convert one type to another, but to tell TypeScript this type is of this or this variable is of this type. So it comes with two different formats. You can use a variable string using the S syntax. When you say variable string, TypeScript is able to automatically say from there on that variable become a string, but you have to assign it to a new variable. And the other option is to use arrow brackets. And in this case, if you say string variable, then TypeScript is able to use that as a string, even if it was a different type. So if you are to do assertions on objects that are incompatible, if you look at the example below, they have a type Y with field name and a type X with field age with a field of age of number. And if I said something like constant Z, which is of a type Y as X, TypeScript is able to look at that and tell me, hey, these types are incompatible and you're probably making a mistake. Please do that. You can override that by using unknown. So basically what you do is if I wanted to overrule TypeScript, in this case, I would probably do something like X as unknown as Y. So this basically overrides TypeScript, but it does make you to do that extra work. So I should say this: avoid using assertions unless absolutely necessary, because, like I said, with any case, there are edge cases that you might want to use assertions. But for the most part, you can use narrowing, especially instead of assertions. The reason for this is because when you're doing assertion, or when people are using assertions, they usually use them in a way that's incorrect, or in a way that introduces bugs into their system. I'll give you a good example for this, is that environment variables. If you're using those in TypeScript, they will always come with as a union. The type is a union of either string or undefined. And what most people usually like is to cast it as string. The problem is whenever that environment variable is not set, because it's something that's coming from an external system, like the operating system in this case, you are cascading the issue into something else, and you might end up causing bugs that are a little bit difficult to track and a little bit to figure out what the exact source is. And some of this behavior you are introducing to the system can have very expensive financial implications. So use assertions as rarely as possible, and always defer to narrowing of types. Another TypeScript introduces the never type, and this is basically assigned to an object that never, to a type that will never happen. So one way you should have to use this is to assign this to generics. So whenever I'm asked on a generic on a field that I know that will never have a value, you can provide it as a never type, and TypeScript prevents you from using this. So you can't use anything with never type. And if a good example is the error I'm providing here. So if you return an error, if you return a function that throws an error, then TypeScript automatically infers that to never. So another good example for the never type is when you do what we call exhaustive type checking. So in this case, we have a function called do something, which accepts X as string or number. And if we were to say, if we were to check everything, every path possible, then the default value, that is the last else block, becomes of type never. So in this case, we are saying if type of X equals to string, then TypeScript automatically infers that a string. If type of X equals to number, TypeScript automatically infers a number. But as you can see, we have a third else block, but we don't have a third type. So in this case, TypeScript will want to look at that and say, no, this will never occur. So you cannot basically use X at that point because you have exhausted possible types for it. Other types worth mentioning, because well, TypeScript is a huge language with more types than most people usually use on a day-to-day basis. So the first one is the first ones are tuples, and tuples are basically arrays whose length is known, and each index position's type is known or predefined. So in this case, we are defining a person or a type whose person name and age, and we are saying in index 0 we want it to be string, and index 1 and index 1 we want it to be number. And you can only provide those two values to that values of those types to that type or variable of that type. Tuples are very useful, and one of the for those who are aware with promise.all, it returns a tuple. When you say promise.all, then provide an array of promises to resolve at once. The response of that is a tuple whose position for each position corresponds to the array that was provided to each promise.all entry, which accepts an array of promises. The second one is union types, and this what this allows us is sort of like to combine different types to create new types. So in this case, I have an example where we are saying it's an environment variable which can be either string or undefined. This is could be done either with literal types, so that it could be on or off for a switch case, or something like null or string for depending on your use case. The third one is functions, and one thing most people usually don't realize, despite using functions in JavaScript and TypeScript, is functions are first-class citizens in that you can create functions and pass them aloud in JavaScript. And this essentially, this is what callbacks are. Whenever you're passing a callback, that's a function that is being passed as a variable. And functions basically allow you to sort of like define the type of function that is going to be accepted by a method. And this is very popular when you are doing functional programming, whereby you can pass functions aloud. And the last one, which I'm going to talk about today, is object types, which is basically anything that has fields in it. So in this case, I have a type of person with name and age, and it could be anything from an empty object, which basically curly brackets without anything there, and anything that doesn't have that isn't the other form of types, that is string, boolean, number, that gets converted to an object. So let's talk a little bit about literal types. The reason I'm talking a little bit about literal types is because the next page you're going to be talking about template literal types, and I usually like to introduce literal types. So for the most part of this conversation, we have been having types of which are broad. By broad, I mean when you talk about string, it could be anything from Angular, TypeScript, it could be my name, it could be your name. But TypeScript does provide you with a way to define very specific or very concrete types. So you can say this type can only accept Wycliffe as the only type, but you can never provide any other value. So you can also use a union of types. So you can say a type and a name will be, or let's say type framework will either be Angular or React or Vue. So in this case, you cannot go ahead and assign it to a different unknown value, because that's the literal types basically basically restricts you to the number of options you have. This is usually built as a good alternative for enums, whereby enums you provide a list of an object. It's basically gets converted to an object with possible values in it. But in this case, the cost of this doesn't exist in runtime, because this gets stripped away from the compiled JavaScript. So the next topic is template literal strings, and I don't know for how many of you are aware about template literal strings, but this allows you to compose strings by inserting variables into a string. So TypeScript does allow you to do this with what we call template literal types. And in essence, what this allows you is to compose types in a similar way, and then TypeScript will be able to generate types out of it. So if you look at the example I'm giving below, so let's assume we are creating a box with smaller boxes in it. So it's going to have a length of 3 by 3. One way we could do that is the second type, whereby we define each coordinate for each box, where we say length 1, h1 for the first box, L1, h2 for the second box, and so on all the way to L3 to h3. But this, as you can see, this is a little bit tiresome because we would have to define each manually. So one thing you can use template literal types for is to create a length, which is 1, 2, 3. And then the smaller boxes can be, you can basically create a template literal type, which basically tells TypeScript. Now use the union above, the union of literal type above there, and then create a new type from it. And TypeScript will automatically create a type mirroring the second one automatically. And the beauty of this is, if you wanted to add, to say, let's expand our box to the length of 4, add just add the fourth number on the length, then it will automatically expand with that. As you can see, this is very useful in some cases, especially when you're doing things with a coordinate system, whereby you're able to play with different combine different types, and TypeScript will be able to automatically generate types for you. So Another topic in TypeScript that is usually very close to my heart is what I really like to call, not really like to call, but it's called type manipulation. So, and this what all this allows you is sort of like to define to create types from other types. So, TypeScript provides what we call utility types, and this basically allows us to essentially take a one type and then manipulate it to have a different meaning. So if you look at the first example of partial type, or partial, which accepts a generic of type. So in generics are always passed in those argo brackets. And whenever you say partial, it basically it takes every high level object, not object, but the field name, and then makes it partial. So in this case, we have a name which is required by default. And once we say partial person, that name becomes possibly undefined or partial. So in this case, what we are doing is taking a type and converting its field into partial or optional field. The opposite of that is required, which basically takes an object and removes any undefined flag on each field. So basically the opposite of the first one. So the first two have their own use cases depending on the source of the object. But the next two, that is the pick and omit ones, are ones that are used on a daily basis. So the pick allows you to sort of create a new type by picking fields from an object. And this is very important without needing to resort to creating a new type manually. So in this case, we have the same type of person with name and age. And what we are doing here in this case, we are telling TypeScript to pick from person, pick age, and we are creating a new person with type age. As you can imagine, this does open the possibilities. Let's say you don't really control the types that are coming from a third-party library, but you don't really need all the fields in that object. So with the pick utility type, you're able to say, from this object, just pick the fields I'm interested in and forget about the others. This is very important. One of the most use case which I use this mostly is during the test use cases, during when you're writing functions and you need to write unit test for. So if you are to have this large object which accepted 5, 6 fields, and you're probably using maybe a couple or at most 3, you'd have to mock all the you'd have to figure out how to mock all the fields, or worse, you'd have to cast it as any in order to provide the minimum number of fields. But by creating a new type using pick, I'm able to create a new type very quickly. That has their own fields that function needs, and very easy for me as a developer to basically mock it out during the test phase. So when I talk about pick, TypeScript does provide the opposite of that, which is called omit. And as you can imagine, this does the opposite of pick. And basically, you just specify the number of fields to omit. Or the fields to omit. And in this case, as you can see, I have type new person, which basically omits name, omits the age in it. And as you can see, we have a new type called with honest name in it. Basically, there is the opposite of pick. The last one is read-only, and this adds read-only flag to each member. So in essence, this is similar to the partial field we discussed previously, in that but marks the fields or high-level fields as immutable, meaning once you assign them values, you cannot reassign the values, or at least TypeScript won't let you unless you decide to overrule it by asserting it to something else. So when we talk about utility types, I just spoke about 5 of them. And TypeScript officially provides about, I don't know, maybe over 10, I'm not really sure. And these have their own different use cases. And then there are libraries such as the one I have highlighted here called Typescripts, which does provide way more useful utility types that help you do different manipulation of type. To give you a good example of one that exists in Typescript but doesn't exist in TypeScript is deep partial. The partial I talked about previously just works on the high level fields, meaning if you had a nested object, those won't be affected. But if you wanted to affect that to every field in there, you can use something we call deep partial. And basically, this is going to go into all nested objects and make sure all of them are made partial or made possibly undefined. So if you get some time, please check out this library. It's amazing. And also start it just to bring awareness to it. So one of the last topic I really want to talk about before I call it a day is generics. And generics allows us to create reusable functions or reusable components that deal with the different types without compromising type security. So a good example is if you had a sort method that can sort an array, how do you tell Typescript to sort arrays, strings, and different types strongly? With generics, you're able to pass in the type using the argo bracket between the function and generic on what type. And Typescript is able to accept that type variable and able to use it to automatically make sure the input and the output match the passed in generics. So these are very useful. And one thing I should remark is that as developers or what we call consumer developers, we don't really have to think a lot about generics, which is why I'm not expanding this into large topics. This mostly matters to library authors who basically have to create libraries that are compatible with a wide array of types while being secure. A good example I have seen recently, I've been able to pick recently has been NGXS, which has to create these complex types using generics. But for the most part, we as developers, we usually use them. And because TypeScript inference is very smart, and it's able to see how you have used your library, it's usually able to infer most of that, and you don't have to think a little bit about. A good example of that is the array.map method. We also have the filter method, which is able to you're able to use that without passing a generic, because a TypeScript is able to check in at the argument that is passed in and automatically infer the type of generic and the type that is returned. So that's it for me today. I was kind of hoping this would go a little bit longer, but I don't really want to go into super advanced stuff. But if you want to keep learning, I have a newsletter currently with just 3 issues. It's called All Things TypeScript, allthingstypescript.dev. Feel free to subscribe when you can. And basically, I usually highlight a few topics here and there, and I'm looking from next week to start adding lessons and challenges, which can help you to keep learning on TypeScript. You can also follow me on Twitter and also read on my blogs where I publish similarly topics in relationship to TypeScript and maybe other topics as well, not just in TypeScript specifically. So that's it for me. So anyone who has any questions, feel free to ask, and I'll answer them to the best of my knowledge.
Yeah, thank you. Thank you very much, Wycliffe. If you have any question, please feel free to unmute yourself and ask the question.
Could Miner probably talk about types and interface? I know sometimes people have a confusion where somebody describes a type and somebody is using an interface, so he can help on that.
Yeah. The reason I don't bring this up is because since the initial version of TypeScript is that the gap has narrowed between the two. There are still some exclusive things available to interfaces that are not available to types, like an interface you can use it to declare the fields in a class or to enforce methods or properties that class is going to have. You can also do things like declaration margin, whereby if you declare the two interfaces in the same file with the same name, TypeScript is able to check the fields and match the properties appropriately. You cannot do the same with types. Other than that, they can be used interchangeably, and most of the time it usually comes down to force of habit. Like I usually tell everyone who asks me that question. I don't really have a strong opinion on either. I usually defer to types, but other than the two advantages, unless you are using something that specifically benefits from those two, you can use either comfortably. I hope that answers your question.
Okay, thank you.
Okay, hi. My question is on the use of never. Could you just go back to and explain again how you use that never type? Yeah.
Yeah. The never type is rarely used because it mostly basically get inferred to TypeScript. But a good example of how personally I use never is, I don't know how familiar you are with okay, if you look at the generics, there are times when you have fields that you specify. I don't have a good example here that I can show you out of the box. But when you say a type is of never, it means that you don't intend to use that type. So the way you usually use it is to mark a field that is whose type is is defined by a generic that I don't intend to use. And I tell when I'm defining that TypeScript, I would say TypeScript. Then, if that field is I don't intend to use that field, instead of marking it as any or unknown, I'll just mark it as never. And the benefit of doing this way is that I won't use that unintentionally. So I'll be, whenever I go to use a TypeScript, will be like that value can never be. This is a little bit complicated to answer without a diagram to show that. So trying to figure out the best way to do it, but the idea being that when you say when you mark a variable as never, it means that it doesn't have any type. So the opposite of any, or the opposite of any type existence, which means if it can't have any type, it cannot be used anywhere because it's never going to happen. I hope that answers that question a little bit.
Yes, thank you.
Hi, Wycliffe.
Hi.
Kindly, can you talk about function overloading in TypeScripts?
So function overloading allows you to define a function that accepts multiple, what we call, that accept different shapes of parameters. So a good example is, let's say we have a function called calculate area. In the first instance, you can say it can calculate the area of a circle. Instead of passing in an object, let's say we are passing in parameters. So in this case, we want to pass in radius. Then we may pass in length and height. We may pass in height. So function overloading, what this allows us is to define multiple functions with the same name. The same thing I did, I previously said about interfaces where we do declaration margin. That's the same approach, whereby you can define a function name with multiple variable names. And then you can declare a type of a function with multiple times. And TypeScript is able to look at that, is able to to overload that function based on the input you're passing in. So in this case, if we had a good example of this is the area example. So let's say we are calculating the area of a circle, which we pass in radius, and the area of a rectangle, which we pass height and length. So a good way to find, we can declare the first type, which is function area, and then it's passing radius, and then it's a number. And then the second one would be width and height as the parameters. And based on how we use that, TypeScript is able to see that and determine and type check our inputs. I hope that does answer your question a little bit. I know it's a little bit more complicated than that, but I can't come up with a better example than that on the fly.
Oh, okay, thank you.
I just have another question. What like why? Okay, I'm not even sure what your stance on this is. Should you always have something of type any or of a certain type, and what are the disadvantages of just putting something of type any?
The biggest problem with using type any is that TypeScript, you are basically disabling TypeScript type checking. So if I have, say, variable x is of type any, TypeScript is not able to check the fields or its type, so I can use it anyhow I want without any consequences. So in essence, you are disabling TypeScript, the TypeScript type checking, and that's the biggest advantage of TypeScript. So you should not be using that because why should you be using TypeScript if you keep overloading TypeScript? Does that answer your question?
Yeah.
And in relation to that,
Anyone else?
Yeah.
In relation to Wayne's question,
Yeah.
what is there a distinct difference between using the unknown type and any type?
Yes, the key difference and the reason why you should be using unknown instead of any is that TypeScript will never allow you to use unknown before you can narrow the type for it. So if you have a variable x of unknown, you cannot use it anywhere unless you first either use assertions to tell TypeScript what the type is, or use one of the methods I discussed earlier for type narrowing to determine the type of it. And any you can use it anyhow you want. So basically, you can pass it in the place of a string or a number, and TypeScript won't complain at all.
Okay. My question was, are you done with that?
Yeah, I'm done. Sorry.
Okay. My question was on the any, still on any. Yeah. I use it a lot when I'm doing API calls.
Yeah.
Because sometimes I just get an overload of data and I want to load it somewhere and then I use it. But from what you're saying, is that we should avoid to use any. And the few times I've not used any, I use an interface. So I'm wondering, am I just going to be creating interfaces for all the API calls I'm making before I manipulate data, or what's the best way to go about it?
Yeah, ideally that's what you really want to do. You want to create to define the types for the data coming from REST API endpoint. Good thing is there are tools that can be able to look at the JSON and automatically generate the types for you. So that makes the job a little bit easier. And there are tools that are coming from REST endpoints that you can also use tools like Swagger, or if you're coming from GraphQL, it does provide a few types to generate the types for you, making the process a little bit faster. But I would recommend taking the time, taking the few minutes to take. I know it can be frustrating having there, whereby you have to define a huge object type. But one advantage you can one thing you can take about one thing you can do with TypeScript is you don't have to define the whole shape of an object. You can define what we call partial types. In essence, what these are is define the object you are using, and then if anything else you are not using, leave it out for the time being. The advantage of this is because TypeScript has what we call property-based typing or dark typing. And as long as the fields that you require are in there, or of a types are in there, as long as there is an overlap between two types, TypeScript allows you to sort of like use one type with more fields in it as another type, as long as it matches, or all fields in the second type exist in the first type. I hope that makes sense.
Yeah, it does. Just that sometimes you want a shortcut in it's moving. You have the data is come, you have seen it, and you just want to go.
Yeah, I understand that. It's sometimes coding is usually a balance between time and creating very good code. But for the most part, I usually think spending that extra few minutes to do that is usually worth it, because you might catch things that otherwise you wouldn't.
Okay.
Yeah, I hope that answers your question.
And probably just to add on to that, it's personally, I had like that kind of I had the same thinking when it came to like how I want to pass data. So I found myself like pretty doing everything to be of type any. And in a way, yes, it was a shortcut, but then when you're looking at it in terms of like how you grow as a developer, it's a very bad attitude towards like really good programming practices. So what I was usually told is that, like, for example, something that comes from an API endpoint, right? It's best for you to like, use Postman, try and get to see how that data is structured. And if you have strings, if you have numbers, just make sure you have that when it comes to the type itself, so that whenever someone wants to come and like mess around with something like passes data over your app or something, it's going to be hard for them because you have a very specific type on how the data come about. So it's very, very important to just use Postman, because you'll be able to test any APIs to see how that data is structured, and you'll be able to now come up with ways on how to, for example, destructure that information based on a specific. But I'd say just start slowly by slowly and do it. It will help you big time when it comes to like starting to land bigger jobs or bigger opportunities, because companies always look at, for example, like how you're coding when it comes to APIs. Like, are you just typing away, or like I'm just accepting the data? Are you checking, for example, what kind of type it is? Like, is it of type string, is it type of number, or you're just accepting it as type any? When you have something that's type any, for some of the companies, that's how you fail your technical assessment. Yeah.
Yeah. Thanks, Wayne, for the input. It's yeah. Like he said, you have to put that little bit of extra effort, similar to what we say about tests, to make sure your program is a little bit more, less fragile, not more, so that you can write better code and more maintainable code in general.
Anyone else has a question? Anyway, so yeah, I'd like to say a big thank you to everyone who attended this session. I think I had a request for you, Wycliffe. Someone asked if it's possible to get the slides after this, if you don't mind.
It's possible.
All right, awesome. Okay, great. So yeah, we'll share everything, share all the details with everyone. Yes?
I have
Valentine?
a request. If you could probably arrange for maybe another webinar on RxJS and behavioral subjects, it would be most helpful, like this one.
Yeah, so we have one. We have a video already on RxJS, which coincidentally was done by Wycliffe. So just go search on our YouTube channel, Angular Kenya, and you're definitely gonna find it.
Okay. Yeah, and just to add to that is we have a course on this is learning for RxJS, specifically with Angular. I think I'll share the links to that as well.
Great. Thank you very much. Yeah, and if you have any questions, I think you can feel free to reach out to Wycliffe on Twitter, and I'm sure he's going to be able to respond. Yeah, I'd like to say thank you. We're gonna upload this video by tomorrow. So if anyone who will not have been able to make it, they'll be able to check it out. Do you have any parting shots, Wycliffe?
Oh, sorry for interrupting. Okay, my name is Melody.
Yes, yes.
Mine is not a question actually, it's away from TypeScript.
Yeah.
Yeah, and my concern is directed to Wayne.
Yeah.
Okay. Okay. I'm a full stack web developer, and there was a Python summit taking place. There will be taking place on 6th and 5th May USIU, and I had tweeted to Wayne, but he has not replied to me. So I don't, and the deadline for paying for the ticket is today. So I don't know the way forward. Yeah.
Okay, Melody, no problem. Just DM me on Twitter, and then I'll take it from there.
Oh, okay. Thank you. Yeah, thank you.
And sorry for not being able to reply. It's been a very crazy week.
It's okay.
Thank you for that. Any parting shot, Wycliffe?
No, at the moment. I hope I was you learned something from me, and feel free to ask me any question. My DMs are usually open. I usually have answered any question anyone has, so don't be afraid. Just get in touch, and I'll answer every question I get to the best. Timing might not be. I might not be able to answer immediately, but I'll try to answer as soon as possible. Yeah, that's it for me.
All right. Thank you very much, and wishing everyone a good evening, and be on the lookout for the next week's session. All right. Thank you, guys.
Bye.
Bye.
Thank you.